Good morning, students. I hope you have studied previous lectures up to the important questions of matrices. Now we will discuss next part, that is part 7 of matrices, and topic transpose of a matrix. Definition of transpose of a matrix. First you have to read it. Let A is equal to matrix Aij be m by n matrix, order m by n. Then transpose of a matrix A denoted by A dash or A to the power T is the matrix obtained from A by interchanging its rows and columns. Clearly, A dash is of order reverse of the previous matrix order. Previous matrix order is m by n, then A transpose is of order n by m matrix, whose jith element is equal to ijth element of A. Here you can see in the example number first. Example number first is a matrix A having elements in first row 2, 5, minus 1. In second row 7, 4 and 0. Order is 2 by 3. When you are transposing the matrix, it means you are changing rows into column. This is row first, this is row second. When you interchange the rows and column, it means 2, 7, this column element becomes the element of the row. 2, 7 can be written as like this. In previous one, A, it is from up to down. When you are writing transpose, it is written as left to right as a row. Second column 5, 4 up to down, and this is written in the transpose 5, 4 from left to right as the second row. And third column minus 1, 0, it becomes third row of the matrix, that is minus 1, 0. Now each row becomes column and column becomes row. Look here, this is column and here it is row. 5, 4 is in column second and here it is in row. Third is this column becomes row. It means order of the matrix becomes now 3 by 2. Previous one is 2 by 3. Now it is 3 by 2. Rows and columns are interchanged. Then you are getting the new matrix. That matrix is known as transpose of a matrix and notation is A dash. Second example for the same is, if A is a matrix having order 3 by 1. Now when you interchange row and column, that becomes the order of 1 by 3. It is written here. And column becomes row. Minus 1, 2, 3, here is up to down elements, column elements. Now when you are writing in transpose matrix, it becomes a row matrix. Elements from left to right, minus 1, 2 and 3. Third example of order 3 by 3, 3 rows and 3 columns. Now first row, that is 0, 1, minus 2, it becomes first column. Second row becomes second column. Third row becomes third column. Because row and columns are same, then order will not be changed. It means 3 by 3 means 3 by 3. Same order will be there. Because 3 is replaced by 3, again you are getting 3 by 3 order. These are the examples to understand the topic transpose of a matrix. Now here are few properties of transpose. Properties of transpose of a matrix. 4 properties are here. For any matrices A and B of suitable order, you have to remember it. You have to take the suitable order. We have what? First property is A transpose and whole transpose. First take the transpose and transpose whole transpose, that is equal to A. Here is the example for that. Take the verification of this property. Take the matrix A here, having elements like this and order 3 by 2. First of all, calculate A transpose. Each row becomes column. Order becomes 3 by 2 to 2 by 3. Now from the left hand side, A transpose whole transpose. It means transpose of the transposed matrix. It means A transpose Further transpose you have to calculate. It means again what? Row become column. What you are getting? You are getting the same matrix which is a previous one, A matrix. A transpose whole transpose comes out equal to A. This is the verification of the first property of the transpose of matrices. Now second property, when you are calculating Ka whole transpose equal to Ka transpose. When you multiply the matrix by K and calculate transpose, you will get the same if you get transpose multiplied by K. Here's example, B part verification. Take any matrix A of order 2 by 2. Find the transpose of this. This is A to the power T. That is, you can write it A to the power T as well as A dash. Minus 1, 3, 5, 2. Transpose this matrix. Row become column. Now, left hand side of the property is Ka whole transpose. Here I am taking K is equal to 2. It means what? I am multiplying the matrix by 2. When I multiply by this 2 by 2, we are getting minus 2, 2 3s are 6, 2 5s are 10, 2 2s are 4. Here I have written 10, replace it by 6. By mistake it is written here as 10. Write it here 6. Okay? Because after multiplication, A by 2, 2 means minus 2, 5 multiplied by 2 is 10, 6, and this is 4. Transpose this matrix, you are getting what? Minus 2, 6, 10 and 4. Okay, transpose it. After transposing, you are getting this matrix. Okay, sorry for that. Minus 2, 6, 10 and 4. This becomes the left hand side of the property. For the second side of this, what you have to do? First, you have to calculate transpose, then multiply by 2. Here I already transposed it. Multiply it by 2 now. Minus 2, 6, 10, 4. In first left hand side, you multiplied first, then take the transpose. In right hand side, you have to transpose first, then multiply by 2. You are getting the same answer. Left and right, both sides will be equal. Now C part, verification of the property. A plus B whole transpose equal to A transpose plus B transpose. First, in left hand side, you have to add the matrices, then take transpose, or in right hand side, first take the transpose of A, then take the transpose of B and add them. Both sides will be equal. Here's the verification. Take a matrix A, minus 5, minus 1, 5, 3, 2, and B is the matrix having element 3, minus 2, 5, 4. According to the left hand side, you are just adding first. Add these two matrices. You are getting corresponding element are added 2, 3, 8, 6. Now transpose this. It means row become column and column become row. Or you can remember it, row become this here is column. Second row become second column. This is a left hand side solution. Now come to the right hand solution. For right hand solution, you have to transpose of A matrix first and then transpose the B matrix. Transpose of A comes out minus 1, 3, 5, 2, 3, 5, minus 2, 4. Add them, you are getting same as we are getting in the left hand side, 2, 8, 3, 6. And verification done, left and right both sides are equal. Now come to the D property. What it property said? AB whole transpose equal to B transpose into A transpose. Remember here, carefully, B comes first, A after the B. B transpose comes first, then A transpose. Now you have to calculate what? From the left hand side, first of all, you have to multiply A and B matrices. Take matrix A and B and multiply them. And you are getting, after multiplication, as you have already studied about it, how to multiply them. You are getting 22, 22, 19, 2. And now take the transpose. As left hand side is written, take the transpose of it. Row become column. 22, 22, 19, 2. This is the left hand side. Now for the right hand side, you have to multiply B transpose with A transpose. B transpose is 3, 5, minus 2, 4. A transpose is minus 1, 3, 5 and 2. Multiply these two matrices, you will get the same as you have got in left hand side, that is 22, 22, 19, 2. Now on the basis of above properties verification, you can do example number 20, 21 and exercise 3.3 and questions of exercise 3.3 from 1 to 6. Now complete these questions in your notebook, and thank you very much.